Hello everyone, so we'll start a new video that is house robbers for today. So this is a series of house robbers problem in which most of the cases it was a dynamic programming question, but this one was a bit different from that. So the binary search is the best approach to do these type of question because if you remember the question that we solved previously, it was like the candies. This problem is similar to that, like most of the thing, like how we think that if this is a binary search problem or not. So most of the binary search problem, they talk about the range in which we have to work or search for a particular thing. So let's just talk about this problem first. So in this problem, we have given a couple of conditions, like we have a robber, and so we have given see these nums. So these nums is that this is the each building, and each building has this amount of money in it, 3, 2, 5, 9, these stuff. So the other thing that is given to us is that the capability of the robber. So it means that the capability represents that okay, the maximum amount of money that he will steal from the houses that he robs. Suppose he robs these two houses, that is 2, 5, 9, right? So these three houses, so the maximum probability would be, or the capability would be 9, right? So this is how we are calculating that. So if we have 2, 5, the probability, the capability would be 5, right? So this is the second thing that we have to uh, look for. And just moving ahead. And the next thing that is given is that the robber, he will not steal from the adjacent house. Suppose he steals from this house, so he will not steal from the second one. Then he will can steal from this house, like so on, right? So he won't steal from the immediate next to it. Cannot steal n+1, but he can steal n+2, right? So these are the three things that we have given for this question, and the acceptance criteria for this question is that we have to give the maximum probability. Sorry, we have to give the minimum capability, right? Suppose in this way, if he chooses this two, then he can choose this five, this 2 and 5, because this is the constraint is that we have to choose at least two, not less than two. We can choose more than two, but it's like you don't, nobody cares for that. So for example, now he chooses three, then he can choose 9. So this is the two pairs that I think we can make. So for this 2, 5 pair and this 3, 9 pair, so in these two pairs, the maximum capability would be for this one 5, this one would be 9, right? As you can see in this one also 9, 9. So the minimum in these two would be, or three would be, is 5, right? So this is the answer that we will get. So if we'll talk about the brute force approach, what I think is that, so the brute force would be like we have to select, if we select this two, and if we don't select this two, then we will like get this value like 5 and 9 with it. But if we don't select two, then we can give 3, 5, 9, the whole array next to that. So after that, then 2, we cannot select 3 now. Then we will select 5. Then we will get the other thing that we don't have anything else. And this one also, like if we haven't selected 2, then we can now select 3, oh, and then 9. Like that, we can select these subtrees. So that way, this can also be like if we don't select 2, then the other values. So it would be a big tree. So that way, this one we can get the answer that this tree will give us 5. So like that, because this is a small one, so it's easy, but as the value grows, it would be exponential. So this is the kind of a brute force approach. Now we will talk about the binary search approach. So as If you haven't watched my previous video in which I was talking about the candies problem, I'll attach the link in the description. So for that question, we have used a similar concept, right? So from the range. So if we can, this is a keen observation that okay, the maximum value that we can get would be, I think, 9. Why? Because the maximum that he can stole is, I think, 9. Because in this array, the maximum value is 9, right? And to start from the range, we can either select from 1, right? Or I simply just take the minimum value from it. So this 2, instead of taking 2, 1, I will take this 2. So this is the range that I will take for my binary tree, sorry, binary search, right? So this is the first thing that we have observed that, okay, so this is the intuition that we will think that, okay, we can use binary search in these type of questions. So now this is our range. So this is the kind of how we can say reward, right? Or the profit that he will get. Not profit would be not a good word, but it's like the money that he will get, right? So this is the first thing that we have observed that okay, this is the range that we can get. So there's one more thing that as you have guessed that in the binary search we have couple of things. The first thing is that we have to apply the binary search which uses 2 pointers, that is left and right. We find the mid, right? And then we check for each value that okay, if it can satisfy any of the condition. So the first we have this binary search, then we have some condition. This is the basic template of binary search, right? So then we have this condition. Then we simply just move. Move means we will go to left, change our pointer's position, either left or the right one, where we have to move. And after that, we will simply return our value, right? Okay, so this is the basic template of binary search. So moving ahead. Now we know that the binary search, we have the while condition, right? So that is left should not be greater than right, or it should be always less than or equal to the right pointer. This is our while condition that we will work on, right? So let's see. So first we will take our left and right pointers, left, right. Then we will find our middle element. So for now, our left is 2, as we discussed, the minimum value, and the right is 9. Okay. So now we will find the mid of it. So 2 plus 9, 11 by 5. It would be around 5, right? So we will go through this array one by one. So this is what I was talking about the condition. So this is the condition part, right? So this is our condition part. So what condition we are having? The condition that we are having is that so we will iterate through each array element, the houses, that okay, so this is the reward or the profit, right? That we are having. So if we can get this is less than 2, so can this value be true? Yes, it can be true because 2 is less than 5, right? So we can get this value. This is the capability M, right? So the capability is like it should be always less than. So this 2 is less than 5. So this is true. So we will simply add our count. Our count would be the value of K. So K basically means that the values he can drop or the houses that he can drop. This is the minimum number of houses that he should drop. So this is the condition. Then we will move ahead. Then yeah, there's one more thing that we have to catch is that if he robs one house, then he cannot rob this house. So he has to rob the other one, the next one, right? So in this condition, like if the condition is true, what we will do, we will increase our pointer. So suppose this is the loop that we will be having. right? So this loop, we have I here. Now we will increase to 2 points, like it will go here. So can be something like I plus equals to 2, right? That way we will skip the next one. So our pointer is here now. So let's check if is equals to, right? Sorry for that. So now 5, let's check, is 5 less than equal to 5? It's true. Then our pointer will increase, our counter will also increase. So previously our counter was 1, now it will be 2, right? If the condition is true, we will increase our index, right? So this index would be plus 1 would be, it will go out of the bounds, out of the loop. So we will break, right? So this is this condition, right? So this is the one condition that we have. So now after that, now we have iterated the loop, we will check. Okay. So what is the value of C now? So if RC or the count is greater than or equal to K, it means that okay, he has robbed enough houses, right? That way it can be our candidate for the answer. So now what we can do? We can simply store this in our result array, right? This value of mid, okay, this reward is can be the answer, right? And one more thing now, if you remember that we are always moving our L and R, so it's time to move the L and R, right? So for example, that if it matches the condition that okay, so we are, so like we if we get the values like the K is sufficient, then we have to move where, so we have to move our right pointer, right? So because if we match the condition, then we will keep our mid. Mid is now 5. We have to get our pointer left side. Why? Because we have to get the minimum one, right? So this 5, we already know that okay, this is satisfying the condition. So we can, he can like at minimum rob 2 houses. So we have to minimize this value. So we will go to the left, right? So we have to move left. So if you remember that whenever we have to move left, we have to increase our right pointer, right? Or move our right pointer. So that would be mid minus 1, minus 1, right? So this is how we move. Okay. So you have already guessed that, okay, if this is not the condition, then in the else part, what we will do? We will simply move our left, right? Not right, I mean left. That would be mid plus 1. So this is the two conditions. So now we will move our right pointer. So our right pointer was somewhere here. So we will move our, this was our left pointer. I will just clean it up. So yeah, these were the previous values that we have encountered, that the left one was 2, the right was 9, and the middle one was 5. Okay, so this is the nums array and this is the range array that we are considering right now. So I have also written some of the code on the left side, so you can also refer to that. So now moving ahead, so now we have to check for each value in M. Okay, so we will go to the nums that okay, we will check the condition that 2, the index is at 0. We will check that okay, if 2 is less than or equal to the value of mid, that is 5. So is this the case? Yes, it is. So now we will just also use the variable as counter. Okay, and so if we choose this value, okay, we will move our index to here, and we will increase the count to 1, because we found one house that we can, not we, but actually that he can rob. Okay. So now moving ahead, so now this 5. We will check for 5. Okay. Is 5 less than equal to 5? Yes, it is. So we will increase our counter. Okay. And we will move our index again to two known values. Now we are out of the index or out of the array. Then we will move to our move conditions. So for the move conditions, we have to check that okay, if count is greater than or equal to k, yes it is. Now what we have to do, it means that we have robbed enough houses to move ahead. So now it means that okay, so we can move to the left side of the range, right? Because we have enough, we can get the enough houses. So that way our left was at 2, right was at 9. Now what this value will do, okay, so we will move to mid minus 1. So mid was 5, so 5 minus 1 would be this one. So our new value of right would be 4. Okay, and also we will store our result. So this is our result. So we'll have the value as mid. So mid value is 5 right now. Okay, understand? Okay, let's move ahead. Now we have to calculate the values again. So we will change the value of R to 4 because this is the new value. And we will again have to calculate the value of M. So 4 to 6 is equals to 3. Okay, we will check for each condition again that 3, okay. So it's 2 less than equal to 3. Yes, it is. We can choose this value. So we will increase our counter to 1 again because this is a new uh, loop. Okay. After that, we will move our index to here. Okay, to 5. Now we will check for 5. Is 5 less than equal to 3? No, it is not. We will simply increase our index again. Okay, because we'll go to the else part of it. Again, 9 is not less than equal to 3. We will move ahead. We will get out of the array. Okay, so now we have to check for the move conditions that okay, if we have the count values greater than equal to k, no, the count is 1. So we'll move to the left part. It means that okay, our range should increase or we should move to the right side of our range because the left side we're not getting the value. So the right side will move. So for moving the right side, we have to shift our left pointer. You're right. So again, we will shift our left to mid plus 1. So mid is 3, it means 4, right? Now we'll check for medium again. So middle element would be 4 again, obviously. So 4, 4, 4. Now this will change the value as right, left, and medium. That would also be in the same place. Now we will check for the array again. 2 less than equal to mid. The mid value is 4. Is it? Yes, it is. We'll choose this value, increase the count, move our index, check for value 5. I don't think it will. Yep, it won't satisfy the condition. Move to the next index, 9. Satisfy the condition. No. Move again. Out of the loop. Right. Check for the move conditions again. What are the values? Count. Okay. Count is equal greater than equal to 2. No way. Okay. We'll move to the left. Else part. So left we have to move. So the left would be mid plus 1. So mid is 4. It would be 5. But for the binary search condition, we have that okay, the left pointer should always be less than or equal to the right pointer. But the left is now ahead of right. So we will get out of the loop, right? So now we will check that okay, what was the result? So in our result, we had the value 5. That was satisfying the condition. So we'll simply return the value as 5 or the value result that we have stored. Okay, understood that? So now we will simply move to the coding part. Now, for uh, binary search, we have couple of things. The first is we have to use the simple binary search template, right? These conditions, and then we have the conditions according to the question, right? Then we will move and will return the value. So this is the basic template of binary search that we have used in couple of questions. Now for the left and the right, we will use the left. For left, I will just simply use the minimum value, minimum nums as we discussed. You can also use 1, it doesn't matter actually. And for the right limit, so we will simply use the maximum values in the nums because the most it can be the maximum value, right? So we will simply use a classic while loop that okay, if while left is less than equal to right, okay, So what we have to do now, we will simply calculate the value of mid. So mid would be, if you remember the trick that we used to prevent the overflow stuff. Okay. So we have calculated the value of mid. Now, if you remember that, okay, we have to check for couple of things. First, we have to get these values count that will increase every time, right? So now we will simply use the value of count. It would be 0 for now, right? And also the index, which we will iterate through this index, nums. This will also change after every loop, right? Now we will move to the next part of it, that is the condition according to the question. So this is basically the gist that, okay, for this we have to calculate the values through these nums, right? We have to iterate through all these values. So we will simply use a loop again, right? So I'll simply use that, okay, while index is less than the value of or the length of the array, right? This looks good. Now, the condition that we will check is that, okay, if the value is, oh, now we will iterate the value, okay. So we will check that, okay, if nums is less than equal to mid, so what we have to do? We have to increase the count and also the index. Now, so if the value of nums, right, is less than or equal to the value of mid, then what we have to do? We have to increase the count, right? That we have robbed this house successfully. And also we have to increase our index to plus 2 value. Sorry for that. Plus 2, else we will simply increase our index to 1, right? The simple thing will do. Now we have to move. So to move our pointers, what we have to do? We will simply use the condition that, okay, if the count was less than equal to k, sorry, greater than equal to k, it means that, okay, we have robbed successful houses, right? Enough houses. After that, we will do what? We will simply move our right pointer, right? We will move to the left because we are changing the right pointer. And also we will simply use the value in variable result. So we will store it as mid. Else we will simply move our left pointer. That would be mid plus 1. And after that, we will simply return the value that is our answer, that is result. I think this is all. If I haven't missed anything or typo, yeah, obviously that would start with 0, I guess. That has passed. So let's submit this. So this has passed, and I think it is pretty efficient. So this was the code for this problem. And let's talk about the time complexity. So the binary search is basically O of log n. Sorry, yeah, O of log n. But we are also iterating through the array again in every iteration. So I think this would be n log n, right? So this n would be the length of the nums. So I think this is the solution for this one. So if you have any doubt or any suggestions, just drop it in the comment section. That's it. Thank you, everyone. So I'll see you in the next one.